Battery systems and motor components have become essential to an expanding range of technologies. Electric vehicles, delivery robots, industrial machinery, automated warehouse equipment, mobility devices, drones and power tools all rely on batteries for energy and motors for movement. Together, these components are helping replace many traditional mechanical and fuel-powered processes with more automated and electrically powered alternatives. However, their growing use also creates important maintenance, repair, reuse, and end-of-life considerations. Batteries provide the portable energy needed to operate mobile and electrically powered equipment. Motors convert that stored electrical energy into the physical movement required to drive wheels, lift materials, operate robotic arms, turn pumps, and perform many other tasks. Battery and motor systems can now be found throughout transportation, manufacturing, construction, logistics, healthcare, and other industries. Their performance directly affects equipment reliability, productivity, and operating efficiency. These components rarely work alone. They operate alongside sensors, wiring, circuit boards, computerized controls, and communication hardware. Responsible equipment management must therefore consider the complete system, rather than focusing only on a battery or motor after it fails. Rechargeable battery systems range from small removable packs to large assemblies containing numerous interconnected cells. Advanced systems may also include protective housings, monitoring electronics, temperature controls, wiring, connectors, and battery management units. Battery capacity determines how long equipment can operate between charges. In a delivery robot, electric vehicle, or automated machine, declining capacity can reduce operating time and create additional charging interruptions. Rechargeable batteries naturally lose some capacity as they age. The rate of deterioration can depend on charging cycles, temperature, workload, operating conditions, and maintenance practices. Organizations can monitor charging time, operating duration, energy use, temperature, and physical condition to identify batteries that are beginning to decline. Maintaining accurate records also supports better replacement planning and reduces the likelihood of unexpected failure. Electric motors transform electrical energy into mechanical motion. Depending on their design, they can move wheels, operate conveyor belts, rotate cutting equipment, power pumps, control robotic arms, and perform many other functions. A motor may contain copper windings, magnets, bearings, wiring, electrical connections, and a protective metal housing. Modern systems often include motor controllers that regulate speed, direction, torque, acceleration, and energy consumption. Motor problems can appear as unusual noise, excessive heat, increased vibration, reduced speed, weak torque, or inconsistent movement. These warning signs should be investigated before they cause damage to surrounding components. A motor problem does not always mean that the complete machine has reached the end of its life. Bearings, wiring, connectors, controllers, and other components may be repairable or replaceable. Battery-powered equipment depends on coordination between several technologies. The battery supplies energy, while power management electronics determine how that energy is distributed throughout the machine. Motor controllers translate operating commands into movement by regulating direction, speed, torque, and acceleration. Sensors provide information about position, temperature, vibration, pressure, speed, and surrounding conditions. Computerized controls interpret this information and continuously adjust system performance. Communication hardware, data cables, connectors, and wireless modules allow the different components to exchange information. This interconnected design can improve efficiency and precision, but it also makes equipment retirement more complicated. A machine may contain a declining battery, a functional motor, reusable structural parts, and obsolete electronic controls at the same time. Evaluating each component individually can help determine what should be repaired, reused, retained, or sent to a licensed recycler. Not every part of a machine reaches the end of its useful life at the same time. Batteries may gradually lose capacity after repeated charging cycles, while motors may develop worn bearings or other mechanical problems after extensive operation. Controllers and sensors may still function physically, but become outdated because newer equipment uses different software, communication systems, or technical standards. Meanwhile, the machine's frame, wheels, enclosure, and structural hardware may remain in good condition. Charging stations, adapters, diagnostic tools, and other accessories also have separate operational lifespans. Some may remain compatible with replacement equipment, while others may no longer meet current requirements. Recognizing these differences can prevent complete machines from being discarded simply because one component requires attention. Component-level evaluation supports better use of existing equipment and reduces unnecessary electronic waste. Preventive maintenance helps organizations recognize battery deterioration before it seriously affects operations. Changes in charging time, operating duration, temperature, energy use, and physical appearance should be monitored. Battery housings and connectors should be inspected for swelling, leakage, cracks, punctures, corrosion, or deformation. Terminals should remain clean, secure, and protected from moisture, industrial debris, and unnecessary movement. Charging equipment should match the technical requirements of the battery system. Incorrect chargers or damaged connectors can create unstable charging, excessive heat, or additional battery deterioration. Employees who regularly operate battery-powered equipment are often the first to notice reduced runtime, unusual charging behavior, or changes in temperature. Clear reporting procedures can help small problems receive attention before they become larger failures. Maintenance records should document inspections, repairs, warning signs, and battery replacements. This information makes it easier to identify recurring problems and plan future equipment needs. Motor maintenance should include regular inspection of wiring, connectors, bearings, mounting points, and ventilation areas. Loose or damaged electrical connections can interrupt power delivery and affect motor performance. Operating temperature should also be monitored. Excessive heat may indicate overload, poor ventilation, friction, electrical problems, or internal deterioration. Unusual grinding, scraping, rattling, or high-pitched sounds may signal worn bearings, misalignment, or damage. Increased vibration can also affect nearby wiring, sensors, controllers, and structural components. Dust, oil, debris, and other contaminants can reduce airflow and contribute to overheating. Motors should be cleaned and serviced according to the equipment manufacturer's recommendations. Addressing minor issues early can extend motor life, reduce unplanned downtime, and prevent a repairable problem from becoming a complete equipment failure. Damaged batteries require different handling from ordinary electronic components. Swelling, leakage, puncture damage, crushing, deformation, and unusual heat are all warning signs that require immediate attention. A questionable battery should not be placed in household trash, general recycling, or a mixed container of ordinary electronics. It should also not be punctured, compressed, dismantled, or forced out of equipment. Organizations should have procedures for identifying, separating, and reporting damaged battery systems. Employees should understand whom to contact when they notice unusual charging behavior, short operating times, visible damage, or excessive temperature. Damaged batteries should be separated from motors, electronics, and other equipment awaiting disposal. A licensed recycler should be contacted before transportation because facilities may have specific packaging, acceptance, and damaged battery requirements. Providing accurate information about the battery's condition allows the receiving facility to determine the most appropriate handling procedure. When a machine is retired, its motor may still retain operational or material value. A functioning motor may be reused in compatible equipment, retained as a replacement part, or evaluated for another appropriate application. Motors kept for future use should be tested, labelled, documented, and stored in conditions that protect them from moisture, impact, and contamination. Even when continued operation is no longer practical, motors contain materials that differ from ordinary mixed waste. Copper windings, steel or aluminum housings, magnets, wiring, and electrical connections may have material recovery potential. Motor controllers should also be evaluated separately. A controller may become obsolete while the motor remains functional, or the controller may still be reusable after the original machine is retired. Keeping motors and related electronics separate from general waste makes inventory, reuse, and eventual recycling more organised. Battery and motor systems depend on numerous supporting components that can easily be overlooked during equipment upgrades. Charging stations, power adapters, battery management units, motor controllers, sensors, control panels, cables, diagnostic devices, and monitoring computers should all be reviewed. Some accessories may remain compatible with newer equipment and can be retained for continued use. Others may be damaged, inefficient, or technologically obsolete and should be prepared for responsible recycling. Monitoring computers and connected control systems may contain operational information, credentials, equipment settings, or other sensitive data. This information should be transferred or removed before the devices leave organisational control. An organised inventory can classify each component for continued use, repair, replacement, storage, resale, or recycling. Good records prevent functional equipment from being discarded automatically during a fleet or facility upgrade. Organisations must often decide whether repairing individual components is more practical than replacing complete equipment. A new battery may significantly extend the useful life of a machine whose mechanical and structural parts remain in good condition. A motor with worn bearings, damaged wiring, or a failed connector may also be repairable. Component-level repairs can reduce costs, limit downtime, and prevent premature equipment disposal. However, repeated repairs on aging equipment may eventually become inefficient. Maintenance history, component availability, operational reliability, energy consumption, and future technology requirements should all be considered. Older equipment may also lack compatibility with newer software, communication systems, or automation standards. Even when repairs are technically possible, the system may no longer meet current operational needs. The goal is to avoid discarding useful machinery too early, while also avoiding continued investment in equipment that can no longer perform reliably or efficiently. Equipment retirement is easier when planning begins before a machine completely fails. Maintenance records can identify replaced batteries, repaired motors, recurring problems, and components that remain original. Each system should be evaluated at the component level. Batteries, motors, controllers, sensors, wiring, chargers, computers, and structural parts may have very different conditions and end-of-life requirements. Functional components selected for reuse should be tested, labelled, protected, and added to an organised inventory. Damaged batteries should be separated immediately, while data-bearing devices should be cleared before leaving the organisation. Separating batteries, motors, circuit boards, cables, controllers, and structural materials prevents complex machinery from being treated as one waste category. A licensed recycler should be selected in advance. Organisations should confirm accepted equipment, preparation requirements, fees, packaging procedures, and transportation options, especially when managing large or damaged battery systems. Electrically powered technology will continue expanding as transportation, manufacturing, construction, logistics, and other industries adopt more automated and energy-efficient equipment. Future batteries may provide greater capacity and longer operating times. Electric motors may deliver increased power while using less energy. Intelligent monitoring systems may continuously track battery health, motor temperature, vibration, and overall performance. Computerized controls will also become more sophisticated, allowing batteries, motors, sensors, and communication systems to work together more precisely. These advancements will make lifecycle management increasingly important. Batteries, motors, controllers, electronics, and structural components will continue to reach end of life at different times. Careful maintenance, accurate records, practical repairs, organised reuse, and advanced retirement planning can help organisations reduce unnecessary waste while making better use of valuable equipment and materials. Battery systems and motor components are essential parts of modern technology, but their value does not end when the original machine is retired. Responsible management throughout the equipment lifecycle can improve operational efficiency, extend useful life, preserve reusable components, and support more organised recycling. For more information, reach us by phone, email, or through our website. Powering modern technology responsibly means managing every battery, motor, and electronic component from operation through end of life.